Welcome everyone to an eclectic view of IBC 2014. So for those of you who are not familiar with IBC, this by the way is a view of the outdoor exhibits at the main entrance. Let me tell you a little bit about it. Unlike NAB, IBC is run by 6 organizations. The International Association of Broadcast Equipment Manufacturers, the IEEE's Broadcast Technology Society, the Royal Television Society, the Society of Cable Television Engineers, SMPTE, and the Institution of Engineering and Technology. So you can see it's got kind of a heavy engineering emphasis, and that comes through in the way the exhibition and the conference is run. It was formerly more exotic even before it moved to Amsterdam. This is an image of the last IBC that was held in England. It was at Brighton and it was on the beach. You can see they had exhibits and tents on the beach. There were some mobile units parked on the beach. But let's just take some category like cameras, and you saw cameras from manufacturers that you never heard of at an NAB show, like EMI and Link and Marconi and Pi. Now IBC is more like NAB. This is one of the 14 exhibit halls. This is Hall 7, and you can probably recognize every name of a manufacturer that's there. They are all NAB exhibitors. But there are some exhibitors at IBC who are not like NAB exhibitors. Let me do a brief overview of NAB versus IBC, just looking at the 2014 shows. At NAB there were 98,000 registrations, more than 98,000. At IBC there were more than 55,000. NAB had visitors from 159 countries. IBC says more than 170. NAB had 1,746 exhibitors. IBC had more than 1,500, so very close. But NAB had 945,000 square feet of exhibit space. IBC about 540,000, so those exhibitors were packed more tightly at IBC than they are at NAB. Now, about those registrations, take them with a grain of salt for both shows. Here is an officially registered visitor, Wile E. Coyote. He has an absolutely official tag. He could go around the show and collect literature or whatever. One of the things that you see more at IBC than at NAB is not only country pavilions, but in some cases portions of country pavilions. So there was the Flanders Pavilion, which is the Dutch-speaking portion of Belgium, and near them was the Wallonia Pavilion, which is the French-speaking portion of Belgium. Here's an exhibitor that I haven't seen at NAB, but they had a very large exhibit at IBC, Gazprom Space Systems. And satellite facilities in general, satellite vendors, satellite organizers, all have a much larger presence at IBC than at NAB. Here is another satellite company I don't recall seeing at NAB before, the Qatar satellite company. And there seemed to be a dearth of ends at IBC this year also. Actually, these aren't Chiron and Miranda. They are additional exhibitors that you don't see at NAB, who go by the name of Cairo and Murata. Now, IBC is also in some ways more consumer-oriented. Philips has a very large booth at IBC, or what at IBC is referred to as a stand rather than a booth, and almost all of it is devoted to nothing but remote controls. And here is a remote control from Ruido that is unbelievably thin, so they refer to it as the Leaf. Now, a little bit more about differences between NAB and IBC. At NAB there are booths, at IBC there are stands. NAB used to have the most U.S. companies, but now almost all of those U.S. companies are exhibiting at IBC as well. IBC started out having espresso machines in almost every booth, and those have now moved over to NAB. and we can only hope that the latest trend at IBC, what you're seeing in the upper right there, is a booth, not a bar, with lots of whiskey, and there were multiple booths that had lots of whiskey, and we can hope that perhaps that spreads over to NAB. IBC was the first to have a future zone, or they call it a future zone now. Previously it was referred to as the New Technology Campus. But NAB now, thanks to Skip Pizzi, has put in a Futures Park, and although it's not very well visited yet, I have high hopes for it in the future. And one strange thing is there's a wonderful European project. You can check some of my online lectures, and you'll see material on Project Fine. Brilliant stuff about virtual camera locations, and I first encountered that at the NAB Futures Park, not at the IBC Future Zone. And then NAB, being in Las Vegas, has casinos and rides. IBC, strangely, has a beach right at the convention center. There's a beach, and you can see a picture of that. And they have fresh new herring, which is just so wonderful, melts in your mouth, very buttery. They also have an EBU Village, which is something we don't see at NAB, and they have an auditorium, and the auditorium has raked seating and is fully equipped for showing movies, and that becomes significant too, as I'll point out in a moment. Now, the picture that you're seeing here is from the EBU Village at last year's IBC, not this year's. And sometimes you see new technology, so the images at the right are from this year's EBU Village. The far right is a 360-degree view camera, and next to it is a 360-degree spherical pickup of audio. But that's not what's really great about the EBU Village. What's really great about the EBU Village is that it's not manufacturer-oriented. So everyone there will be happy to talk to you about any subject that you want, really, conversion from SDI to IP technology, going to some form of UHD, higher frame rate, higher dynamic range. And because they're broadcasters, or in some cases academic institutions, they'll just give you their view on it, and they're not trying to sell you anything. So it's a wonderful, refreshing place, very large, and they sometimes have lectures there too, which are wonderful. Now, I was mentioning that auditorium, and so IBC puts on a big screen track of seminars that relate to what happens in cinema auditoriums, and one of them was event cinema, more than just TV on the big screen, and I happen to be the moderator of that session. And here is one of the things that we saw there. The new season of Doctor Who began with a cinema transmission, or a viewing in cinemas. They were in 1,559 cinemas in 98 countries. They used 15 languages. They sold 650,000 tickets, but because the tickets are not so cheap, they grossed for that one single showing about $16 million. So $16 million for one episode, one showing of a television show is pretty darn good, I think. But here's another interesting thing that happened in that session. This was Sony showing that they sent the World Cup in 4K to the Westfield View Cinema. And notice one thing here. You can't really tell that there's 4K resolution on the screen, but you can see that there is light coming off the screen and illuminating the walls and the ceiling of this cinema. And that's pretty significant, as I'll show you in a moment. What you're seeing here is the last 10 minutes of every transmission of the Metropolitan Opera HD Live, which goes to cinemas worldwide. The Met has even more cinemas than that Doctor Who, and although not quite as many countries, they're in more continents. The Met is on all 7 continents, including Antarctica. But this last 10 minutes of this slide is specifically to get that light spill. when the Metropolitan Opera transmits an opera, it's transmitted live. The projectionist doesn't know exactly when it's over, so the projectionist doesn't know when to turn on the exit lights, so the Met provides its own exit lighting. Try to remember this lighting concept because I'm going to discuss it in a moment on a completely different context. Now, because of this big screen track at the IBC auditorium, one of the things they do is they show recent movies, and so two of the movies that were shown this year were The Life of Pi and Dawn of the Planet of the Apes, and both of them were shown with the Christie 6P laser projector, which is extremely bright, so even in 3D it was able to deliver a full 14-foot Lamberts of screen brightness, peak screen brightness, and they had Atmos surround. Now, because it was the 6P projector, which has effectively 6 color primaries, it was also used for some wide color gamut demos, and people remarked that it was really amazing. They could see tremendous differences between normal color gamut and wide color gamut on that screen. Now, NAB sometimes does Technology Summit for Cinema, where they gather lots of people and they show things on fairly big screens, but it's a large conference room. It's not a cinema auditorium, and it really does make a difference. Another thing that was shown at the big screen at IBC was Doug Trumbull's Magi process, which was 4K spatial resolution in 3D at 120 frames per second. So amazingly vivid images, and he showed a short that he did with that system called UFO TOG. Now, that wasn't the only place that 120 hertz or 120 frames per second was shown at IBC. In the future zone, NHK was showing 8K images at 120 frames per second. And as you can see from the bottom, they were also showing a wider color gamut. If you look at the roses on the bottom right and compare them to the roses at the bottom left image, you can see a significant difference in color there. Whether you like what you see or not is a different matter. And near them, and just across from them, was this booth, which was the Forever system. And notice that they're showing better colors on the left, better contrast, then better motion on the right. But the one they're calling better images in the middle, that's the one with higher resolution. So a lot of people have been talking about, do we want more pixels or faster pixels or better pixels? Well, that's kind of a loaded question. So it was nice to see that Forever was using the term better in a different context. But high dynamic range, which I certainly favor and I think delivers the most bang for the buck, is certainly spreading, and Dolby's perceptual quantizer was incorporated in the Ikegami HDK 97 ARI, shown here in their booth with a high dynamic range monitor right in front of it. Also, at several stands, you could see material that had been shot by a Grass Valley camera at the Zurich European Athletics Championship, and it was shot at 1080p 50 frames per second with the perceptual quantizer, and they were also showing a wider color gamut and higher resolution. Now, there are different 4K acquisition philosophies. We could try picking up 4K exactly the same way that we pick up HD, but use larger sensors so we're not cheating ourselves out of contrast, and use a prism camera. And the image that you see at the top there, this was not at IBC, but it was a camera that was built by Lockheed Martin. There was a paper about it in the SMPTE Journal in 2001, and you can see it's a rather large camera and probably not the kind of thing you're going to put on a shoulder. So what most of the manufacturers of quote-unquote 4K cameras are doing is they're using a single large sensor, like the red camera that I'm showing at the right. But there's a problem with that, in that that single large sensor, if it's the size of a Super 35mm frame, cannot use the long-range zoom lenses that are common in sports coverage or concerts or award shows or something like that. And at IBC, Canon had not yet introduced the lens that I'm showing at the lower left. It was introduced at the SMPTE conference last week. And that's a 20-to-1 zoom. That's now the highest range PL mount zoom that there is for a Super 35 sensor. JVC, by the way, also coming up with a Super 35 size sensor for a 4K camera. But here are, before I get to that, let me tell you about a camera that was introduced at IBC, the Alexa 65. This is a camera with a sort of 65mm image sensor. It's actually larger than the aperture on Ari's 65mm film camera, and seems to have something like 6.5K of resolution rather than a mere 4K. But it has an even more limited range of lenses that it can use. But what we'd like to be able to do with a higher resolution camera is use it again in sports and concerts and award shows and the like with the kind of long-range zoom. So I'm showing down at the bottom right a Fujinon 101-to-1 zoom that's 5 times more range than even on this brand new Canon lens that came out. Canon, by the way, also makes a 100-to-1 zoom for those kind of cameras. And there seem to be two philosophies on that. One was introduced by Grass Valley at NAB, which is to use 2/3 inch high-definition sensors and just up-convert the output. And there's a lot to be said for that, because all of the optics match, the filtering matches, everything is perfect, and so the up-conversion is going to be very good. And then Hitachi introduced at IBC a new concept, which is 2/3 inch sensors, but 4 of them with 2 greens and a 1/2 pixel diagonal offset between them. The concept was originated, I think, by Olympus a number of years ago. So here is the Hitachi camera, and it's showing just a 27-to-1 lens on it, but it is a broadcast standard B4 mount, and it can take an 88, 99, 101-to-1, any B4 mount lens on it. But to me, one of the most significant things about this is at the right of the camera, down near the bottom, and I've put a red box around it, under Hitachi it says Gearhouse Broadcast. Now, I normally don't talk about any sales, but in this case I think that the sale was very significant. Gearhouse bought 50 of these cameras at IBC, and they did that precisely because they can use the B4 lenses that they already have. There was a lot more discussion about 4K at the show, but a lot of it was for this kind of thing where people were saying, okay, it's good to acquire in 4K even if you're going to distribute in 2K, 2K being essentially HDTV. Here were some other futuristic things at the show now. Starting off with the 4K, Sennheiser says they deliver the sound that 4K demands. Nothing especially 4K about that sound. In the future zone, there was a Japanese company called Three Dragons, and they were showing what they called the Holo-Deck, and obviously I can't reproduce for you here what they were showing because it involved a rotating mirror, but it was a kind of interesting 3D effect and looked sort of holographic. You could walk around and see different sides of it. And then we have this egg in the middle for TSL, which was being used to demonstrate their surround sound microphone. And then at the Samsung booth at the upper right, I'm showing a curved very large screen and also very wide aspect ratio, a sort of cinemascope aspect ratio, and that's for immersing you in a picture without going to 3D. And then down at the bottom right, I wish I could tell you more about this. This was at SGO's booth, but it's not an SGO product. It's the larger screen that you're seeing on the left there. And it's from Stream TV Networks, but they've got a branch of it that's called Ultra D. And this was a 4K screen, and they were showing HD material with sub-pixel control because it was a 4K screen. And there is some kind of optical processing. The person I spoke to said there was no barrier and no direction of images to eyes, but I looked at their website and it seems that maybe there is some kind of direction of images to eyes. I don't know what's going on, but it does seem to give you a 3D effect, and it is controllable, and there doesn't seem to be a particular sweet spot. So I wish I could tell you more. Maybe you will learn and you can tell me about it. There's the website there, ultra-d.com. And let's not forget sound again. So last year at IBC, Penguin Engineering Bureau in Germany did some testing of surround sound systems. And this year they presented the test results. And as you can imagine, everyone felt that if you had more immersive channels, the sound was more immersive. But there was one interesting factor in this chart, and that is if you already have surround sound, which is that top bar, then people are less likely to be excited by the really immersive systems. So it's kind of like there is an asymptote. There is a point where we get diminishing returns for going to either more immersive sound or more detail resolution or any of those things. Now here's an image at the partners area at IBC. At the left is Barbara Lang. She's the executive director of SMPTE. And at the right is Danny Wu of Facebook. And they are exchanging contact information via something called a token. Each of them has a token that was part of their badge lanyard, and you could just touch those together and get the contact information. This picture, by the way, appeared in the SMPTE Motion Imaging Journal in October. I had one of those tokens, but most of the people that I wanted to get contact information from didn't, because they had exhibits-only passes. And so when I turned in my token, I did not have any single person on it whose contact information I had gathered. That was part of the Content Anywhere section of IBC, and this was the Content Everywhere booth at IBC, and every time I went past it, it seemed to be empty. So IBC was more this year, in my opinion, a let's solve today's problems rather than a let's figure out what we can do with tomorrow's issues kind of show. This was another booth that had very few people in it. They have a Wi-Fi flat satellite antenna. So you put up this satellite antenna and then it distributes internet via Wi-Fi. Maybe not so exciting because of the delays that are involved in that, but for whatever reason, the booth was not crowded. But this was a much more crowded booth. This was Make TV's booth on cloud-based live production. And let me expand the images there just above the TVs. And you can see that you contribute sounds and images to the cloud studio, and then you do cloud publishing, and then your audience can interact with that and affect your cloud publishing. And that raises an issue of how do we measure the audience for the kinds of things that are happening today on smartphones and tablets and computers as well as TV sets. So one of the announcements at IBC this year was that SMPTE and the Coalition for Innovative Media Measurement have joined together on a project for ID binding, so that even if somebody takes just a little tiny snippet of something, you'll be able to figure out where that snippet came from, what it's all about, and be able to measure the audience for it. Here was another announcement at IBC, actually several announcements. This is from the Digital Production Partnership, which is a UK organization, and one of the big things that they were announcing was that as of October 1st of this year, they will no longer accept for any UK broadcaster any material, program, advertisement, anything that does not comply with their delivery standards. So that was quite a big deal for the UK community and for people who deliver to the UK community, and that's the bulk, I think, of still the IBC audience. But for those of us not involved in the UK community, there was Netflix. This is their familiar red envelope, and they announced at IBC that they are requiring anyone who delivers content to them to conform to the IMF standard, and that is how they will be accepting their content, and they will not accept things that are not IMF. And then they also made a decision that the way to make IMFs for them will be through the Fraunhofer EasyDCP software, which just got expanded to include IMF. Now, Fraunhofer had a bunch of other interesting things. They always do. And at the left, you are seeing the light field capture camera. They've shown various versions of this at NAB. I think they had a 6-lens version. This is the largest one I've seen with a 15-lens version, and this is the first time that I saw a faceplate for it. So it's like they're turning it into sort of a product. And then speaking of product, down at the bottom right, you're seeing the Avid plugin for this. This is one version of it that you're looking at, which is showing 16 images. They came up with a version that just shows 4 images, the 4 extremes. Now, why do you care about those 4 versions? Because one of the things that you can do with a light field camera in post is you can reposition. And this year they were showing not only repositioning and refocusing, which they had previously shown, but also now you can zoom and track. You can change the effective position of the camera by making use of the light field capture. And here was a little bit more from Fraunhofer. They showed audio manipulation detection and included electrical network frequency analysis. Now, let me speak about that for a moment. Anytime you make a recording, even if you're using battery-operated equipment, there's probably some leakage from an electrical network someplace that is getting into your recording. And their system is now sensitive enough that they can detect the, in our country, 60 hertz power frequency, in Europe, the 50 hertz power frequency, which varies very slightly over the course of the day. And they can identify any phase discontinuities and any change in frequency. And by doing so, they can tell whether something has been edited or manipulated. And they can also identify fingerprints and tell who originally made the recording and therefore who has pirated it. Now, another interesting thing at IBC this year was a lot of stuff on object-based media. There was a great presentation by the BBC in the Future Zone, and I recommend you go over to the BBC website. You don't have to memorize everything that's on there. Just look up object-based broadcasting BBC and you'll get to that website. And there are some videos on there that show how it improves interactive, personalized, immersive, and accessible media. And then from a commercial standpoint, there was the Pixel Mosaic, which can be used on different devices and helps you find what you want to see, but it's different for those different devices. Object-based media adjusts the relationship of different objects to match the kind of device and environment in which you are using it. Now, a lot of people have been using things like smartphones for citizen journalism. You see a bank being robbed, you whip out your phone, you shoot some footage of it, you call up the TV station, and you sell them your footage, and they get this wonderful footage of the breaking news. But what happens if there's a news story that you want to cover, but you can't send a crew there for whatever reason, all your crews are busy or something, but you can't count on some citizen journalist just happening to be there and shooting it? Well, Bobo came up with this great system where TV stations and other news organizations can actually schedule citizen journalists. They use geolocation to find out where people who might shoot something are, and then tell them, hey, why don't you go over to this thing and shoot it? And then the editor chooses whichever is the best video and buys it, and everybody's happy. The consumer gets the best video, the person who shot it gets some money, the editor gets things happening. It was a very interesting ecosystem for journalism. By the way, I see that someone wants me to explain a little bit about what light field capture is. We are accustomed to image capture, where we use a lens, and the lens forms an image on a plane, in most cases an image sensor in a digital camera of some sort, or in the old days on a piece of film. And what's on that plane is a picture. It's the kind of picture that you see on a TV set, or on a movie screen, or on a photograph, or in a newspaper or magazine. But just before that lens, before the light gets through the lens, there is a field of light that contains all of the information that's in there before the lens does its focusing or zooming or aperture control. So if you could somehow capture that information before the lens, then you can manipulate that in post-production as though you had the capability of adjusting the lens in post-production. So that's why previous light field capture things primarily would allow you to change focus, because focus is one of the things you can do on the lens. And now that Fraunhofer 15 camera thing allows you also to zoom, and by using some tricks, they can also now track, so you can effectively use the same lens focal length and quote-unquote move the camera, but you're actually just moving where you would have that lens in the light field capture. But continuing on with the idea of solving today's problems, I would say that probably everybody at some TV station has at some point had to use Skype. You know, you've got a correspondent someplace where there's just no phone lines, there's no satellite circuit available, so you use Skype. Except, how do you get Skype into the broadcast system? Well, you could aim a camera at a computer screen. There are worse things that people have done. But 3 companies at IBC this year came up with a new way of dealing with Skype, and they worked with Microsoft, and they have broadcast versions of Skype. There's the New Tech Talk Show at the left, the Riedel SDK 200 at the upper right, and then below that the QuickLink TX. And all 3 of them have broadcast connections, SDI, embedded audio, non-embedded audio, XLRs, BNCs, everything that you need. And the New Tech one goes even a step farther, and they can adjust audio-video delay if necessary. But even with all of that, you still have a problem, and what I'm showing is an intentionally bad picture that's part of a tutorial that a different company, VC, is showing, which is lighting for video. You know, make sure you have good lighting. But again, if you're dealing with a correspondent out in the field and it's a war zone, then maybe lighting isn't going to be an option. And so when I was discussing this with NewTek, I said, hey, how about applying something like that Metropolitan Opera exit lighting and make most of the screen white, so the screen is actually providing the lighting for the correspondent. And the NewTek people immediately came up with a name for it. Cloud lighting, which I think is a great name. Also, lots of speech recognition at the show. Several European Union projects, multilingual speech recognition, machine translation, automatic transcription, and then because automatic transcription, as we all know, sometimes makes some colossal errors. There was that famous story of the older couple that was going to Disney World and sent a message to their children, and the message came out, we are getting divorced, rather than we are going to Disney World. So the Tosca project has as part of it crowdsourcing of quality control to take care of the issue of machine translation. And then the BBC Kiwi project, even more interesting to me, that they're doing speaker separation. Yeah, we already have dictation, there's Siri, there's things in Android where you can dictate a message, but how do you separate things when two different speakers are talking and when they don't speak carefully as they might do when they're doing dictation? And by doing this kind of stuff, they can go back into their archives and index the archives automatically based on the speech recognition. So pretty exciting stuff. This was an introduction at IBC, the SanDisk Extreme Pro, which is a 512 gigabyte SD card. This is a little tiny, roughly 1-inch high SD card, and has a transfer speed of 95 megabytes per second. So roughly 8 times that in terms of megabits per second, approaching 800 megabits per second. It's a very, very high-speed card. This was another cute small thing. This was at the DECTEC booth, an all-band, all-standard modulator. You just stick this into your USB port, and you can be a television station in whatever standard you want. And frequency, agile, all you need is an amplifier to get this out there, an amplifier and an antenna, and the right to do it, I guess. And then here was a new device from Timecode Buddy, the Pulse, and this not only broadcasts timecode and slate information and provides sync, but this can do wireless camera control, and notice that it's got 2 spigots on it for that. You can do 3D camera control of 2 cameras and simultaneously control them. And so that's a quick overview of IBC 2014 with the strange statue of the Queen outside, and with a statue of someone standing in front of the Queen, and with that wonderful, delicious herring. And I will now entertain any questions if anyone has any. And we have a question: can the light plane be used to generate 3D? I guess the light field, yes, absolutely. Capturing the light field does allow you to generate 3D. You can adjust all of the things that you would normally adjust for 3D in shooting, the toe-in, the interaxial distance between the 2 images, and you can adjust it constantly, and you can do that in post-production.